Hi everyone, I am Dr. P.R.A. Kimiri, working as a professor in the Department of IT at V.S.B. Engineering College, Karur. So in this video, we discussed about the basics of cryptography. So the outline of this video is, first we discussed regarding introduction to cryptography, then we discussed about the symmetric key cryptography. So what are the needs of using this cryptography and what are the requirements? Okay, so if you want to send the information confidentially to other persons, if you want to do the communication confidentially, or you want to do the how to do the transaction, then we need some security. So for that security purpose, we use the concept of cryptography. If we want to do the cryptography, then what are the requirements are needed? So there are three requirements. One is secrecy, second one is authentication, and third one is message integrity. What do you mean by secrecy? So the sender send the message to receiver. So what is the secrecy in that? Only the receiver receive the message. Intermediately, any persons cannot receive the message. So that is the secrecy. So you have to understand only the intended recipient receive the message or not. Then authentication. So what do you mean by authentication? Sender and receiver need to confirm each other identity. That means whether the corresponding sender only send the message, and also receiver sender assume that the corresponding receiver only receive the message. Message integrity. So during the transmission, the message can be altered either maliciously or accidentally. So if it is integrity means that corresponding message cannot be altered. So that is the integrity. So what are the basics of using this introduction to cryptography? Cryptography is one of really this science of art. So using this art, we have to hide the original message. So there are two components in this cryptography. One is encryption and another one is authentication and integrity. So what do you mean by encryption? So you have to send the original message. That message not directly send in the actual form. You convert that message into some other form. That is called as a hiding, or that is called as a encryption. So if you do the encryption process, third party cannot read the message. Then what do you mean by authentication and integrity? So either ensuring that users of data or resources or the persons they claim to be and that a message has not been altered. That means only the corresponding sender only send the message. The corresponding receiver only receive the message. During the transmission, it cannot be altered. So we have to ensure it. That is authentication and integrity. So what are the terminology used in this cryptography? So first one is plain text. Plain text means that message is in a readable form. The original message is called as a plain text. It is in a readable form. It is denoted by M or P. Then encryption, that means encipher. That means you have to encode the message. Original message is converted into some other form. That is called as encoding the message. It is not in a readable form. It is denoted by the letter E. Ciphertext. The encrypted message is called as a ciphertext. It is denoted by the letter C. That means it is in an unreadable form. The original message is converted into ciphertext using this encryption technique. Then decryption. Decryption means you have to decode the ciphertext. That means it is possible to receive the original message after performing the decryption process. It is denoted by the letter D. So this is encryption and decryption. How do you do the encryption and decryption process? Okay, so this is encryption algorithm. This is the decryption algorithm. For this encryption algorithm, have to pass the original message. So that message is converted into ciphertext. Then that ciphertext is passed as an input to the decryption algorithm. Then after perform that decryption algorithm, then you get the original message. So D of C, that is equal to M. That means decryption of ciphertext, that is equal to original message. So here what is C? C is nothing but encrypted message. For doing this encryption and decryption, we need the keys. Next, we discuss regarding this keys. Okay. So now we discuss about the algorithms and the keys. So what are the algorithms we use for encrypting the message? Then how that encrypted message is converted into original message using this decryption algorithm. Okay, so a method of encryption and decryption is called a cipher. So encryption, you have to convert that original message into unreadable form. Decryption, we have to convert that unreadable form message into original message. Generally, there are two related functions, one for encryption and another for decryption. Some cryptographic methods mainly rely on the secrecy of the algorithm. So such methods, we have to use that either in the encryption or decryption, not only the original message or ciphertext, not only the input. We have another input that is called as a key. So all modern algorithms use the key to control both encryption as well as decryption. Okay. So key-based encryption, decryption. So for doing that encryption and decryption, we use the keys, not only the message or the ciphertext is not only the input. We use the keys, we convert that original message into ciphertext. Similarly, using some keys, we convert that ciphertext into original message. Okay, so there are two cases. One is symmetric case and the other one is asymmetric case. So in symmetric case, both encryption as well as decryption algorithm use the same key. That is, single key is used for both encryption and decryption algorithm, or it is derived from each other. What do you mean by asymmetric case? Keys are different and not derivable from each other. That is, for encryption, we use one key and decryption, we use another key. We did discuss about that concept in asymmetric key. Okay, secret key cryptography. So what do you mean by secret key cryptography? So sender send the message to the receiver. Through that transmission, the original message is not directly passed to the receiver end. The converted message only passed to the receiver end, and the receiver decrypt the message, and then it is possible to read the original message. Okay, so for this, we use the secret key. Okay, so how do you do that process? Sender sends the original message to the encryption algorithm. This encryption algorithm receive another input as a key. So in this symmetric case, both encryption and decryption algorithm use the same key. Okay, now this encryption algorithm convert that original message into ciphertext using this key. Then next part, at the receiver end, this ciphertext is passed to the decryption algorithm, and this algorithm also receives the same key. So what are the key? What is the key used for encryption? The same key is used for decryption. Now the original message is converted in ciphertext message is converted into original message at the receiver end. So here K is the secret key shared by both sender as well as receiver. Okay. So in that secret key cryptography, so it is called as a symmetric key or single key algorithms. Then the encryption, that means encryption and decryption use the same key for converting the original message into ciphertext and converting the ciphertext into original message. So this technique is based on the combination of substitution and permutation process. We did discuss about this combination, what is substitution and what is permutation. Okay. In this secret key, we use either the stream cipher or a block cipher technique. Stream cipher means it operates only on the single bit or a byte. But block cipher means we have blocks. That blocks typically contains 64 bits. So advantage of using this secret key is it is simple as well as fast. The disadvantage is how we securely transmitting the key. So that is most important. Key exchange and key management is a challenging task in that some secret key cryptography. For example of this secret key or a symmetric key or single key algorithm, DES, RC4, IDEA, Blowfish, AES, etc. So this is the main concept of this private key crypto system, that is symmetric key symmetric key crypto system. Okay, so in that, this is at the sender side and this is at the receiver side. In the sender, send the original message. That message is not directly sent. It is encrypted using the key. So then we receive the ciphertext. So ABC is converted into some other form. Now, this is at the sender side. Now the ciphertext is passed to the receiver end. So receiver passed the ciphertext to the decryption algorithm using the key. and convert that ciphertext into original message. So for both sender and receiver using the same secret key. So it is called as a symmetric key encryption. Okay. So in this symmetric key, how many keys are used? Suppose if you use the two parties, if you use two parties that use only a single key. If the communication involves three parties, then we need three different keys. Then if the communication parties have four parties, then we need the 6 keys. If 5 parties, then we need the 10 keys. So how do you calculate this key management? That is P into P minus 1 by 2. What is P? P is nothing but number of parties. For example, if we have 3 parties, then how many keys are required? 3 into 3 minus 1 by 2. That is 6 by 2. Totally 3 keys are needed. So what are the assurance for secret key? So it provides the confidentiality, authentication, integrity, and non-repudiation. That means what? What do you mean by confidentiality? The message securely transferred to the receiver. That is a confidentiality. It means owners of shared secret key can decrypt a message that has been encrypted with a shared secret key. Then what do you mean by authentication? The receiver ensure that the corresponding sender only send the message. Or sender assume that the corresponding receiver only receive the message. So they have both sender and the receiver that have confirmed that identity. Then integrity is the assurance that a message has not been changed during the transmission process. That is called as a integrity. Then non-repudiation. That means the sender cannot deny the particular file was not sent by me. It is not possible to deny that. This cannot be done with the secret key alone. Okay, that is called as a non-repudiation. So these are the some assurance used in the secret key. So next class we detail discuss about what is the public key cryptography. Thank you.